doing today is we're starting with these shaded region style problems, and we're figuring out the points at which they intersect each other. These points where they intersect one another is where we're able to find what are called maximums and minimums of these shaded regions. Now, we're going to be given specific constraints, we're going to be giving specific stuff, but one of the first things we're going to do is we get rid of the graph paper.
Oh, no.
We get rid of the graph paper. Can you please put your feet down? Thank you. So we get rid of graph paper because we have to start to be able to visualize these setups a little bit easier. Now, when you're given these lists of constraints, that's what these inequalities are called. They're called constraints. What we do is we just rough sketch our graphs. Now, with the first two inequalities that were given us, it tells us something about this graph. It tells us where the graph is going to be located. And where would that be?
First quadrant.
Correct. It's a first quadrant problem. Do you guys agree?
Yes.
X is greater than 0, greater than equal to 0, y is greater than equal to 0. So we know right away we get a first quadrant problem because x greater than 0 is that way, y greater than 0 is that way. And I'm going to use these arrows to help us, instead of shading so much, these directional arrows tell us the direction in which the shade is going. That way it's a little bit cleaner as we go through. Now we go ahead and, in this case, we wind up with some real nice, easy, quick graphs. So what's your x-intercept on the first one? Negative 15, and your y-intercept is 5. So I know y-intercept at 0, 5. Uh-oh. But my x-intercept is negative 15 and 0. Well, I still connect my lines, right?
Uh-huh.
I'm just not worried about it since I'm told to stop at anything past the first quadrant. I just don't worry about that second half of the graph. But I still have to figure out which direction to shade. Does it go through the origin? No. Is 0 plus 0 smaller than 15?
Yes.
Yeah. So I know it's going this way. So I know that I have this point where it's going to change because it's making me stop at 0. So it's going to start working its way down here. So right now my graph is in this general vicinity. Do you agree so far? It's being enclosed. And then I find out my x and y intercepts again with the next one. 6 and 12? Do you agree?
Mm-hmm.
X is 6, y is 12?
Yeah.
And then is 0 plus 0 smaller than 12? Yeah. So it's inside here. So it's inside this four-sided box, or four-sided figure.
Oh,
You know, the fortagon, otherwise known as a quadrilateral.
I'll see.
What's a quadrilateral? You're getting confused about Vortigon.
Sorry. Potato, potato. So as of right now, do you guys agree that there are 4 places in which this graph changes directions?
Yes, sir.
Right from looking at this graph now, we already have 2 of them labeled. 0, 5 and 6, 0. What's one of the other ones? 0, 0, because it happens at the origin. And then we've got to figure out this point. Well, that point is the point at which the 2 equations intersect one another. That's the point where these 2 guys intersect. So if you think back to how we solved those back in 3.2, solving systems of equations. So what you do here is you solve for x and y given that information. When you go about that with all of these types of inequalities, you really don't worry about the inequality symbol here. You just say it's negative x plus 3y equals 15. Treat it like that as you're solving for x and y. So we're going to figure out some way of using elimination, substitution, or something along those lines to figure out how we want to set this one up. I'm going to multiply the top equation by 2 and just rewrite it right below there. So I have negative 2x plus 6y is 30. By doing that, I now have opposite signs with same coefficients, so all I have to do is just add the 2 equations together. 7y is 42. Y is 6.
How do you get from inequality to the equality.
I just said that. I said when you're solving for the systems, when you're trying to figure out where they intersect, treat it like an equal sign. So my value at this ordered pair is going to be something 6. Well, what's x? Yeah. 2 times what plus 6 is 12?
3.
Good. So what we're doing here is we're going to be able to figure out where these lines intersect one another by using systems of equations. We're going to be able to find the shaded areas by using this graphing of systems of inequalities. And then the next bit is you list them. 0, 5, 0, 0, 6, 0, and the other one was what, 3, 6?
Yes.
Because what's going to happen now is that each one of these problems also comes along with what's called what they call an objective function. It's what you want to maximize or minimize. It's something along the lines of, let's say you make $4 profit on selling pens, and you make $3 profit selling paper. So your objective function would be 4 times P for pens plus 3 times R for paper, that example, for figuring out your overall profits. The problems will give that to you. They will give you those values. When we get to the word problems later on this week, it won't. You're going to have to figure out the constraint, the actual equation. But after we get into that, it's really not difficult after you learn how to read these. So I'm going to make one up real quick. It's going to look like this. It'll say C is 2x plus y. And you want to figure out what's the maximum value given that function. Yeah? No. Not matter at all. I start one point and work my way around. And all you're doing when you have to maximize or find the maximum or minimum in some of these? Yeah. It's 2 times 0 plus 5. 2 times 0 plus 0. 2 times 6 plus 0. Happy feet, stop. And you just figure out which ones are which. What you're doing is you're taking those sets of ordered pairs. Those are the points of inflection that these graphs change shape. That's where maximum and or minimum values can occur. Sometimes they're bounded within each other. It's a closed figure. Sometimes it's not a closed figure. Yeah. I just made it up. The problems will come along with it. Okay, that C, that objective function, they use the letter C. Well, I don't know. It'll be in each problem itself. In each one of those objective functions, it looks a little bit different, but it's something along those lines. And you just figure out which one's the greatest value, which one's the smallest. 5, 0, 12, 12. So that's weird, I have a shared maximum. Doesn't happen every time. But that's basically what we're looking at. Okay? Once again, same exact idea. We are done with graph paper. This is how the wording looks in your book. Find the maximum and the minimum of the objective function. C equals 3x plus 4y, subject to the following constraints. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 8. What you're doing, once again, is you start by graphing. You start by graphing and figuring out what the shaded region looks like. Once you figure out what that shaded region looks like, you get your ordered pairs. And once you get your ordered pairs, you substitute into the objective function, see which one's larger, which one's smaller. And that's it. So all we're doing is taking a step further into what we did yesterday. Because the only thing that's different from yesterday versus today is that we're listing out those ordered pairs. Whereas yesterday we just had to shade everything. Okay? So if I'm looking at these 3 constraints, what quadrant am I in again? I'm first quadrant. I'm first quadrant problem. And what are my x and y intercepts? 8 and 8.
8 and 8, yep.
Is that shading outward or inward?
Inward, sir.
Inward. So, because that line didn't go through the origin, so I used my test point 0, 0, and it was true. So does everybody see how I have, you basically graph a triangle?
Yes, sir.
Now, from there, yes. Cover and solve, y-intercepts 8, x-intercepts 8. So now from here, I know that I've got those 3 ordered pairs, 0, 8, 8, 0, and 0, 0, to substitute in to my objective function. Three times 0 plus 4 times 8. 3 times 0 plus 4 times, oops, excuse me, I wrote this back. 3 times 8. And then lastly, which one of those did my maximum occur at?
0, 8. 0, 8.
0, 8. My maximum occurred at 0, 8 because that's 32. So here's my maximum. Yes, sir. Oh, no question. And then my minimum here is at 0. And I come down. And that's what we're doing. Figuring out where you're going to have a maximum and a minimum value. Because the reason why we find maximum and minimums is because you'll be able to answer a question that sounds like this. Certain airline sells business class and tourist class seats for its charter flights. To charter a plane, at least 5 business class tickets must be sold and at least 9 tourist tickets must be sold. The plane does not hold more than 30 people. They make a $40 profit on each business class and $45 on each tourist class ticket sold. In order for high-fly airlines to maximize its profits, how many tourist class seats should it sell? So what you're doing here is that you have to be able to pick out of that information constraints and what your objective is. Well, your objective is to maximize your profit. So as we get into these things, this is where this is going to lead us. It's going to lead us to be able to answer a question like this once we know how to plot it. And once you get one of these under your belts, shall you say, how you set them up, they're all the same. They're not, it's just different words. Okay. That makes any sense. They're all the same, but just different words. Sure.
I understand.
Thank you. Try this one. Take a second and try. Same idea. No graphs.
What is
No graphs. We have x is greater than or equal to 0. Y is less than or equal to 2x plus 2. And 5 is greater than or equal to x plus y. I know that it's going to be, this problem itself is going to be somewhere within the first and the fourth quadrant. Do you agree?
Yes.
All values of larger than 0 for x. It's going this way. From there, I start working on my intercepts. I know my y-intercept for the second inequality is at 2. My x-intercept is at -1. So I don't care about that side until I get here, and I'm going this way. All right. Did that go through the origin? Is 0 smaller than 2? So it is shading this direction. Okay. And then lastly, I put in my graph of 5 is less than, or excuse me, 5 is greater than or equal to x plus y. So I have x and y intercepts of 5s. Connect them. And then is 5 larger than 0? So it's true at 0, 0, so it's coming inward again. So now, this does continue, doesn't it? Is there a minimum value occurring here? There is no minimum value. There's no bottom. There's no way to stop it. Okay? So if that's the case, if there's no bottom to it, or if there's no lid to it, I would say that there's no minimum, or I would say it's no maximum. So this problem has no minimum value. Okay? There's no minimum. But I can still figure out what my maximum is. So now, according to my graphs here, it only appears as if my graphs change direction in 2 spots. They change, if you follow the x up here, it changes here, and it changes there. So I have to figure out this ordered pair, but I know that one is at 0, 2. You with me on that? And now to figure out what the ordered pair is where those 2 guys intersect, I have to solve the system of equations, y equals 2x plus 2, and 5 equals x plus y. What's that? Don't even bother. Do you have one of the equations already set up as y equals? Use substitution. I'm going to use substitution in this real quick, and I'm going to get the following. 5 is x plus 2x plus 2. I'm just using substitution here. X is 1. What's y? 4. I used substitution. I already had y by itself in the first inequality, so I just substituted in the second one. Solve for x. Systems of equations, just like we did last week. Okay. So now you just have to substitute both in 0, 2 and 1, 4 to figure out which one's the maximum. I think it's going to be pretty obvious which one's going to wind up. Which one's bigger, 10 or 21?
10.
Bingo! Here's your max. You get it? Bingo, 21? Not bingo. Blackjack. Yes. No, you did. Good job. So that's what this looks like. I did. I mistakenly said bingo for blackjack. Yes, sir.
Can you go over again how we did the points that?
Where they intersect?
Yeah.
It's called systems of equations.
Okay. So we just take the 2
Yep.
equations and.
All you're doing here, you had y equals 2x plus 2, and 5 equals x plus y. In this case here, I'm using direct substitution. I know that y is this.
Okay, so what if it's like?
Then you have to use some linear combinations like we did last week. I told you guys none of that changes. You gotta remember how to do that. If you're not remembering how to do that, you gotta come and see me and get help. Otherwise, you're gonna get lost real fast.
I think I'm alright now.
All right. Yes, sir.
Why does the last one not have a minimum?
Because there's no bottom. There's nothing in the graph here that stops it and it puts a bottom to it. It's open because it's all the values of x are going this way, and this is coming down this way, and this line is infinite. So there's just no bottom here. There's no other graph to stop it.
That's because there isn't a y. A y is less than or greater than 0.
Correct. There's nothing like that. Or it could have been any other. It could have been any other, just another inequality that went through like that. It could have been something along those lines. But since there's nothing there, there's no bottom to it. There's no bottom boundary to mess around with. And that does happen from time to time. It could be no minimum, and it could be a no maximum if it's flipped around, and it's got an open top. Okay. No. No, because because that's this one right here. Do another one. Minus 2? I don't remember. I'll do this one instead. Our objective function is c equals x, 5x plus 6y. I want to find the maximum and minimum values of that with the following constraints. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is greater than or equal to 5, 3x plus 4y is greater than or equal to 18. What's that? No, not really. Get a flex pass. So, do we know, in this case, do we know approximately what quadrant we are working in? Yeah. Alright. Now remember, not always are you going to be given the first quadrant problem. But just so happens this one does. So I got a first quadrant problem. And does everybody understand why I'm putting arrows and not shading?
Yeah.
Okay. So you will get lost in our shades.
I got lost last night.
The third inequality, I have x and y intercepts of 5. Do we agree? So it's 5, 0, and 0, 5. So is 0 plus 0 bigger than 5? No. So I'm shading outward. Okay? Everybody see that so far?
Yes.
All right. In the next one, I have x-intercept of 6, a y-intercept of 4.5. And once again, is 0 plus 0 smaller than 18, or larger than 18? No, so it's false going this direction, so it's moving outward again. So now, is there a lid to this problem? No, there's going to be no maximum. We can see that right now. There's no max. But, yes, ma'am?
So now wouldn't there be another point where they intersect?
Yes, and I was just about to change colors to show that we got to find this point right here. And is that what you're getting at, Shay?
Yeah.
Perfect. Now I have to figure out what that point is where they intersected. Because those two lines cross each other. That means right now we are bounded down, we turned right again, and went this way. So the 3 points I have to worry about are going to be at 0, 5, whatever that new one is, and 6, 0. This new point occurs where those two graphs intersect, which means I have to use some sort of linear combination or something or another to figure that out. Since this case here is x plus y is greater than or equal to 5, I'm just going to say x is 5 minus y. You okay with that? I'm going to use substitution. So I'm going to substitute in. So I get 3 times 5 minus y plus 4y is 18. Remember, when I'm solving the systems part of these, where these two lines intersect, I don't care about the inequality symbols anymore. I'm just using equality. Because I'm just solving where they run into each other, not worried about any shading or anything like that. So I have 15 minus 3y plus 4y is 18. Y is 3. If y is 3, what's x? 2. Very good. There's that other point. So from there, all I have to do is substitute those values back into the objective function, and I know that I don't have a maximum. Is everybody in agreement that we don't have a maximum? Yeah. And why is that again? There's no lid. There's no lid. What's that? Yeah. So now we just have to figure out where the minimum occurs. So it's going to be 5 times 0. Oops. So we have 30, 10, and 18 is 28, and 30 again. So my minimum value occurred here. Okay? That's what we're working on today. This is the kind of stuff we're working on today. We're trying to figure out a best guess of where things intersect, where our maximum and minimums are occurring. Don't use graph paper. Rough sketch it. Use your intercepts. Use your quick graphs. Use arrows to denote where your shading is going. And tomorrow we'll go over these and build into the word problems. Of course. Let's start on these.